So just going to back to the slideshow from the current slide. All right, so we had just finished doing ionic compounds, so now we're going to deal with nomenclature of covalent compounds. So covalent compounds are much easier because we don't have to figure out anything with charges. All right, the name will tell us the formula. You can't predict it because you can combine, you've even seen with carbon dioxide and carbon monoxide. The name is going to tell you the formula. So we use prefix, first element name, prefix, second element, and we put an ide, I-D-E suffix. And the prefix is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right, so these are the easiest as they can be. Carbon disulfide, it literally means carbon and two sulfurs. Carbon, two sulfurs. Sulfur hexafluoride, sulfur, 6 fluorines. Sulfur and 6 fluorines. Dinitrogen pentoxide, 2 nitrogens, 5 oxygens. 2O5. All right? So hit pause, try these. Now I'm going to do it. I hope you're back from pause. So carbon tetrabromide can be CBr4. Sulfur difluoride, SF2. Dichlorine heptoxide, Cl2O7. See, as easy as it can be. All right, so that takes care of covalent compounds. Now, the last one is acid nomenclature. So acids are tricky, right? We haven't really talked about acid-base chemistry, and we're just going to do it briefly, and it's towards the end. Basically, an acid is like an ionic compound. I did mention a while back, hydrogen acts like a metal when it's in an acid. So think of an acid as an ionic compound where hydrogen is the metal. If you look at the periodic table, hydrogen is in group 1, so its charge should be +1. The formula is always going to be H, and then that's the rest of it. And then we usually use this subscript. This is called a phase label. AQ means aqueous, which means it's dissolved in water. Right? Acids come in 2 flavors. There are binary and not binary, and I'll go through each one of these separately. All right? So binary acid, meaning there's only 2 elements, that means it's H and another element. The name is hydroxic acid. So for example, hydrochloric acid. Oxyacids, or you can say anything that's not binary, it's going to be H and a polyatomic ion. So first we're just going to do, are the acids binary or are they not binary? And I'm not going to bother to click on the answer slide. You can do that in the home version. That would be my alarm system. You've heard this before. All right. So hydrobromic acid means it's hydrobromic, excuse me. Hydro means it's a binary acid. So hydrobromic acid, okay. Iodic doesn't have the prefix hydro, therefore it's not binary. Nitrous, not binary. Hydroiodic is binary, and the phosphoric is not. So you're just looking for the prefix hydro. If it begins with hydro, it's a binary acid. That's simple. If it's a binary acid, you just look at the other element, figure out its charge. Again, treat it like it's an ionic compound. Hydrogen's a +1. So if we look at these 3, hydroiodic, hydrobromic, hydrosulfuric, hydroiodic means the other ion is iodine. So think of the charge. Okay. Bromine, sulfur. Now sulfuric acid exists, and so does iodic acid, so those are different than hydro. So just going to the answers, hit pause, try it on your own. Okay, and you're back. All right, hydroiodic, the other ion is iodine. Iodine is a -1, and we've gone through how to figure that out. So if you need to review the slides, do it on the PowerPoint, not obviously on the video, because the video you can't advance. So it'll be HI. Good habit to write AQ. Hydrobromic, the other ion is bromine. Bromine is a -1. So H is a +1, HBr. hydrosulfuric, the other ion, would be sulfur. Sulfur is a -2. All right. Back. All right. So that takes care of binary. The other acids, the naming is what's the pain. Okay, coming up with the formula is fine. But the way this works is you look at the name. We're going from name to formula. So really look at this backwards. If the acid ends in ic, then the ion it came from, or the other ion, is the 8 ion, right? So again, to figure it out, you need to know what the other ion is. H is a +1, all right? So, and if the acid ends in us acid, then the ion was the ith. So for example, go to a slide here, all right? So first of all, coming up with the formula is pretty easy if you know the charge. For every negative charge, you have a hydrogen, right? So sulfate would be a -2, so there's 2 H's. Phosphate. Now, this is the naming part. If the ion ends in 8, the acid ends in ic, and so on. So for example, if the name we're given is chloric acid, that means the ion is chlorate. Chlorate is ClO3 with a -1 charge. That means the acid will be HClO3. So you kind of have to go roundabout here. If you're asked chlorus acid, us means the ion was ith. I would love to have been at the meeting where they came up with this because I really want to know what they were drinking, but this is the system we have. All right, so remember, one of my colleagues used to say, remember, if you ate it, it's ick. That's all I got. All right, so if the ion is ite, if the acid is us, the ion is ite, so chlorite is ClO2 with a -1 charge. That means the acid would be HClO2. All right, once again, hit pause. Try these on your own. All right, you're back from pause. So I'm going to go through them. So remember, if the acid ends in ic, the ion is 8. So iodic means iodate. Iodate is an IO3-. Again, how do we know this? This is a polyatomic ion. You just got to know them. It's only one negative charge. We need only one hydrogen, HiO3. Always write the H's first. Carbonic acid, ic, 8. See that? Ic, 8. Ic, 8. Carbonic acid, carbonate. Carbonate's a -2. That means you need 2 hydrogens, H2CO3. Okay? Us, ite. Phosphorus. Why is it not phosphorite? We're just going to do the best we can on that. Phosphorus, phosphite. Phosphite is PO3. 3 negatives. That means 3 H's. Okay? So that's tricky, but again, none of the steps are difficult, but there's a lot of steps. Make yourself go step by step. All right. So this is it for going from the name to the formula. So once again, I'm going to ask you to hit pause. And while you're hitting pause, okay, you hit pause. Try them on your own. All right, now you're back from pause. So let's go through them. Magnesium nitride. First thing, what type of a compound is it? Magnesium is a metal, ionic compound. Then it's get the symbols, right? Mg, nitride is N. Get the charges. Mg is a representative metal, and therefore, and this is where you're using your periodic table. So it's in group 2, it's a +2. Whoops, jumped the gun there. Nitride is a nonmetal, okay? Nonmetal, and it's in group 15, so 5 minus 8 is -3. So then you just have to put them together. We have to get to a 6 here because of the 3 and the 2, Mg3N2. Iron 3 acetate, okay, we have 2 clues that this is ionic. So iron is the transition metal. So transition metal means an ionic compound. Then we get the symbols. Iron 3 means it's Fe with a 3+. Acetate is a polyatomic ion. So you're looking on that polyatomic ion list. It's that monster there. So it's going to be, we need 3 of these to counteract the 3+ charge. Sulfur dioxide, all right, again, sulfur and oxygen are nonmetals. That means this is not an ionic compound, excuse me, this is covalent. So covalent compounds, we just look at it. Sulfur that doesn't say anything, so sulfur and 2 oxygens, SO2. Hydrofluoric acid, Okay, so this is obviously an acid because it begins with hydro. That means it's a binary acid. That means it's just going to be H and F, H plus, F minus, so just BHF. And then nitrous acid, this is not binary because it does not begin with hydro. Nitrous acid has a polyatomic ion. The polyatomic ion must be nitrite because it's us, right? Ion is nitrite. Nitrite, you look up, NO2, -1 charge, so it'd be H plus, NO2 minus would be HNO2. All right, so that's it going from the name to the formula. We're going to go the other direction. Before we do that, I think you can see this is something that's going to take you a lot of practice. So while you're learning this, while you're practicing it, doing homework 8, studying this, I would literally have sitting out on my desk, make yourself some space, a periodic table, the list of the polyatomic ions. I would have this first flow chart. I think that should be plenty to help you out going through this, but certainly those few things would help you with this. And just look things up as you get better at it. If you look up something 10 times, you don't have to look it up 11. All right, so this will be the end of this set, then we'll start another set of slides, or I'm sorry, another video in a moment.